Okay, hi everybody. In this video here, we're going to take a quick look at what we call the difference quotient. Now, this is an important expression in calculus, but for right now, what we're doing is we're looking at it more in terms of what it means for understanding functions and function notation. So we're going to construct and simplify the difference quotient, which is f of x plus h minus f of x, and that's all over the variable h. And we're going to do this for the expression f of x is equal to the square root of x. And we're going to simplify this as far as we can. And I'll let you know where we want you to stop. And it'll be the similar sort of starting point for all of these sorts of questions here. So what we're going to do to start off with is we're going to evaluate this. So we've got f of x plus h minus f of x all over h. We're going to substitute in, and we're going to use the function here. So f of x, what the f of x does here is it takes the square root of whatever's inside it, I should say. So f of x plus h is going to be the square root of x plus h. Minus f of x is going to be the square root of x, and this is all over h. Now, at this point here, you might look at this and say, okay, well, I've substituted it in. Doesn't seem like there's a lot that I can do. Maybe I'm done. But actually, we want you to simplify this, and I'm going to show you what I mean by that. We are going to have to rationalize the numerator here to get what we want to pop out of this. So I need to get rid of those radicals. The fact that I've got this x plus h, because there's this h under the radical right now, I'm not thrilled with that. So I'm going to multiply by the binomial conjugate. Okay, and so this is a fairly frequent, well-known tool for rationalizing. When I multiply that through in the numerator, I'm creating this difference of squares expression. So what that's going to do is for that square root of x plus h, it's going to cancel that square root. And then I'm going to have at the end here that root x being squared to get that negative x. Now, remember, there's going to be no other terms there. We use the binomial conjugate simply to make sure that we don't have any other terms showing up in there. That's the beautiful thing about the binomial conjugate. Love it. Now, once I do this, notice that my x's are going to cancel. They're going to have that x minus the x. And when that's done, notice that the h's here also cancel. And that's really what we're looking for here. 1 over the square root of x plus h plus the square root of x. Now, do I still have an h in there? Yes. But I do not have an h as a factor anymore in the denominator. Okay? And so we might include here that this is true so long as h doesn't equal 0. You're going to see later on when you start working with this expression in calculus that that's actually not 100% necessary, but it's a good thing to throw in there right now.